Welcome to another episode of AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. Today's episode is brought to you by our sponsor, Infineon Technologies. Infineon is well known for its microcontrollers among its many other product lines, and it's recently introduced some AI-enabled system-on-chips called the PSOC family that include AI accelerators from ARM as well as Infineon's own. They're designed for the IoT, small sensor nodes and battery-powered devices everywhere. Infineon's also recently acquired a startup in Sweden called Imaginmob, a tiny ML toolchain and platform company to help round out its AI portfolio. All this is against the backdrop of somewhat tentative adoption for AI in end device markets, whether that's in the industrial or the consumer IoT. I had a chat with Infineon's Sam Jaha. He's the Executive Vice President of the IoT, Compute and Wireless business at Infineon Technologies, to try and get some perspective about what might be happening with AI in the IoT. Here's my conversation with Sam. Okay, so I'm very pleased to welcome to the show today Infineon's Sam Jaha. Sam, thank you so much for joining us.
Thank you. Thanks for inviting me to your podcast, Sally.
Really what we're going to talk about today is about how we're kind of well into 2025 already, and I'm still hearing that Edge AI in IoT devices is kind of a buzzword. Really what I wanted to ask is, why do you think AI in the IoT hasn't reached its potential just yet? What do you think is holding back adoption of this potentially very powerful technology for small devices and battery-powered devices? What's holding us back?
Yeah, Sally, so what we're experiencing so far is that the biggest challenge is of the adoption process is what we call the ecosystem. And what we mean by that is starting with our end customers. Our end customers don't have data scientists and PhDs in model development and optimization. That's why internally we are trying to help them by developing what we call DeepCraft Studio, which gives the developers the option to bring their own data and create a model, or use our ready-made AI models, or start from scratch by doing data collection and building their models. So for me, this is kind of what's holding people back and why it's taken time. And developing that ecosystem with AI acceleration, with tools to support the developers is the key to the future success. Although I would say it's coming, and it will come. So the other thing is I call it the chip designers or the hardware designers are realizing that you also need more memory at the edge in order to support these growing models and the sensor data. And in order to do that, so to be an effective edge AI solution, the MCU must collect large amounts of data and execute sensor fusion and have the capability to run ML models. So you have to solve for it on the hardware side, and you have to come up with models, that help the end users and the developers.
Let's dive into some of these areas a little bit deeper. I know you're talking about the ecosystem in the first part of your answer there. I know you said developers don't necessarily have the AI experience that are developing these kinds of devices, but what's missing? And how has this been kind of holding us back? What can we do to help?
Yeah, so let's do an example. Let's say you're the guy that's an expert on designing coffee machines, right? So you're the coffee maker. And what's missing is how many people do you need to hire? How many software people do you need to hire that can say, okay, in how many ways I can order coffee? Okay, well, there's maybe 500 total words where you can say latte with sugar, with cream, whatever, and maybe in 100 languages. And so now the question is, I'm really a hardware guy. I'm a guy building the machine. I know how to mix the right ratio of coffee, but I don't have the software experts to understand words and all that. So what we're doing at Infineon is we bought a company called Imaginmob which design development of an end-to-end platform for developing AI and machine learning on the edge. And we are pairing it with our hardware product, which what we call PSOC Edge. So we have rebranded the name Imagimob to what we call DeepCraft. And we're providing the platform with tools and flexibility for developers to customize their models to their specific needs. And obviously, optimize it to work with our PSOC Edge platform. So if you are that guy that's trying to have the solution, we're also trying to figure out, okay, if you don't want to hire these software people and you don't have the models, we can provide you ready models. We can develop those for you. You can go to a third party to make these models for you, and then we can integrate them. So that's kind of, to me, call it the next frontier here of how to solve this problem at the highest level.
Yeah, because designing an AI product, if you're making your own model, is super challenging. Data set collection, curation, and Imagimob, or now DeepCraft, kind of provides all of those services, right?
Yes, they do. And, we're even training other external companies to say, okay, you don't have to go with Imagimob. Besides, I would say they can only support a few customers. But if you really, we're trying to open up the ecosystem where there's a lot of other design houses, other places that can actually do the models for you. And, I know we'll talk a little bit later about security, but at the end of the day, the biggest value or expense for these customers is actually the models themselves. And that's why what we're seeing is many of our customers really care about protecting those models. And in some cases, the model itself cost a few $1 million. And they want to protect it. They don't want to have somebody else to access it after they spend a lot of time developing the model itself. So therefore, the hardware needs to be super secure, and we'll talk about that a little bit later. But that's kind of one of the elements of how this comes together.
To what extent is it really about educating embedded designers about AI models and how they work and what to do with their data? Education must be part, right?
Yes, absolutely. And I think initially, I will tell you, our journey is we're starting with the large customers that have lots of developers and software people and can do it by themselves, and working on adopting or improving the system and the offering to make it simple enough where, I'll give you the simplest experience. I call it the best out-of-box experience. It's like, you got to point somebody to go to our website, and then they go figure out what product to buy, what kit they should order with it, how to download the software with the kit, how to get access to either ready developed models or say, okay, I'm going to bring my own models, and how to design it, including using our PSOC Edge product. And, and so we're trying to make that journey easier and even create community where people can actually discuss amongst themselves, hey, this is how we did it there, etc. And my best example is, I'd say my wife has become a YouTube engineer, right? So watching a 5-minute YouTube video, you can always come up with, this is how I do it. This is how I, just kind of guiding and making things easier for our developers to access data. Okay.
That sounds great. Can you tell us more about DeepCraft and what that product offering looks like from DeepCraft now, and what might be coming up for DeepCraft in 2025?
Let's put it this way: we're working on various models that could be immediately call it downloaded via DeepCraft, right? And we launched 3 things, right? Edge AI software, branded DeepCraft, where we do off-the-shelf AI models. We have DeepCraft ready models, and we have what we call DeepCraft Studio, which is a platform for AI model development. So you can actually, and that's the one that we're introducing next year, meaning you can actually enter the data and it helps you make the AI model, for the various applications, right? So that's what's coming next year with it. Today we have, I would say, a few examples still of it, I don't know, baby crying, siren. We're making one about snoring, so you can tell. Like we're working on various projects there that just to kind of test it out and to see how simple it is, for people to come up with their own AI model. Okay, and so I would say pairing it up with our PSOC Edge is really the focus for us for the next year.
Got it. Thank you. Going back to our three kind of key areas from earlier, you mentioned about bringing down system cost. Adding AI, we're effectively adding features to this design. So I guess it stands to reason that cost would be more, right?
Yes. I would say until now is only MPUs, based on performance capability will support AI functionality. And what we have done in the last 2 years is we've introduced an MCU product, not MPU, to enable AI at the edge. And I would say outperform the MPU's solutions with two factors. One is cost, and two is power consumption. So with MCUs, you actually can match the performance of the MPU, but you do it with a lot lower power. In some cases, even up to 200x energy saving. And with the system cost, that's half the total cost of the MPU. The reason for that is with an MCU, you don't need an expensive memory, you don't need a PMIC, you don't need other components for the application processor. They're already integrated in the die. And the neural network acceleration built into our PSOC Edge has a pretty fast inference time. So like less than 50 milliseconds for a YOLO V5 model, which means it's just as efficient as an MPU. My personal belief is that as the costs come down, the world will adopt AI a lot more. So really our goal is to bring the solution from being a $20 solution to a $10 solution to ultimately a $5 and a $3 and a $2 solution. And that's our focus. And we believe the cheaper it gets and the easier it gets and the lower power, especially to support, portable devices or battery powered devices, that's the direction we will be going.
So you mentioned the neural network accelerator, the NPU there you've got in the PSOC family. I know some family members in the PSOC family use ARM Ethos NPU, yes. For example. Can you tell us more about why you picked that NPU and how you've implemented it?
Yes. So the ARM Ethos U55 is implemented in our PSOC Edge architecture. What we did is we combined the Cortex M55 that introduced the Helium DSP with Ethos U55. And the reason we did that is we decided to come up with what we call a multi-stage architecture, where we can do both high performance and low power. So you want to be in both domains and not simultaneously. But, so if you think of the real example of, and I'm not trying to take away from Amazon, but Alexa. You want to wake up Alexa, right? You want to be in the low power domain waiting to hear a word like, hey, Alexa, do something. But once it wakes up, then you want to be in high performance mode, right? So this architecture allows us to process high performance compute tasks by leveraging the Cortex M55 and pairing it with the U55, but we also have the ability to turn that domain off and have our low power domain also with Cortex M33 and Infineon's NN Lite to handle the always on use case. So you don't always want to be in the M55 mode. You want to be in the low power mode initially in many cases.
Yeah, I guess this idea of power modes or different power modes and different parts of the chip turning off and so on will be very familiar to embedded designers. This is just an extension of principles that already exist, right?
Yeah, that's correct. And I think, though, some people just focus on performance, some people focus on low power. We try to combine the two with our PSOC Edge product, which we think is a differentiated product. And really, NN Lite allows us to handle this always-on type of use cases. Think about mostly for word spotting, for wake word detection. The reason we use NN Lite, it can accelerate the ML models by 4x versus just the pure M33 in the low power domain. So it's more of an accelerator in the low power domain that we use it.
Would it be, so let's say listening for a wake word or a keyword using the NN Lite accelerator, and then if you hear it, then switch on the Ethos to do some more kind of processing, like which kind of keyword was it? It's more like different parts wake up as needed, right?
Correct. That's exactly it. And this is more on the architectural side, but please keep in mind that we are targeting many applications that are go beyond this. So yes, we are focusing on the waking up the device, but I want to just let the audience know that, we're after many examples. And we think, for me, image recognition, voice detection, all these reasons, all these applications are great opportunities for us to, expand the applications and the portfolio. So, but our architecture is flexible and is able to work with all of these. So,
can you tell us anything more about NN Lite? I think people who listen to this podcast know a lot about AI accelerators, or they should do if they've been listening for a long time. Is it a MAC array or something more novel, or can you tell us anything about how it works?
I think, first of all, it's a little bit of an internal secret code, so it's a little bit hard to tell you, but it is invented by Infineon, and it's really focused on handling the always-on type of use cases. So I would say I would leave it at that, and the only thing I would tell you is it works, and it basically allows you to process high performance compute tasks, and in the low power mode. So okay.
Yeah, that sounds good. I have to ask. Okay, coming back to our key points then, I think security was another interesting area that you mentioned, which I know is a huge deal for IoT and the IoT devices that are everywhere. Why is security such a difficult problem to solve for the IoT, and why is it a particular problem for AI-enabled devices?
Yeah, so it's a great question. So first of all, maybe a quick background that Infineon, I would say, is a leader in security, and leader in security because our products are in your credit card, right? And that are protecting the chip that's in your credit card. They're in the US, EU, and Chinese passports. So, so we have been experts on security for many years. And when you think security, you think, okay, how do you protect the data? In this case, the data is your, ML models, right? And you want to keep looking for ways to make sure the data is protected and is not attacked, right? So, the people, I call them hackers, are getting smarter, right? And there's many features you start worrying about, like things from secure boot, secure firmware over-the-air update, physical fault detection, fault sensor management system, all these cases. Like sometimes when you do any interrupt, those are opportunities for the hackers to access the data. And it started really with one of our top customers, and they said, look, yeah, we'll buy your die for $5, but really we're going to spend millions of dollars developing the model. So number one, the only reason we would go with you is if you can prove to us that you could be what we call PSA level 4 secure. And so I would say we're proudly, our PSOC Edge product is actually a PSA level 4 secure, and it's the first chip in the world that's an MCU, AI MCU that can do that. And it is now a feature and a differentiator for us. So I would give you another example. Another customer said, yeah, we want to get to AI at some point, but we really want to buy you because of your PSA level 4 security right now, because we're trying to protect the credit card data. And then later we will work on it to enhance security. And so hopefully this answers the question at the highest level, right?
Yeah.
So, yeah.
So I'm curious about PSA level 4. From the AI perspective, I'm curious about what level 4 actually means. Is level 4 appropriate for all of IoT applications, or what does it actually mean?
Yeah, I don't think, okay, so let me, before we get to the level 4, there's really 5 essential machine learning embedded security essentials, I call it. First is the general MCU embedded security hygiene. Mm-hmm. Okay, you want to mitigate hijacking of the machine learning model's host processor, the memory, the peripherals when you're booting and when you're running. 2 is you want machine learning model confidentiality, right? You don't want, you want to make sure, obfuscation from the supply chain. You want to make sure in-field ecosystem security against DPA on the models. You want the machine learning model integrity, right? Mitigation on the chip against malicious changing parameters. You want extra confidentiality focus, right? On the secure storage. You want sensor integrity. So with all these, you need, you would say you need the highest level of security, right? And that can withstand these highly sophisticated attacks and protect the sensitive assets, typically used in critical applications. I mean, if you have a secure camera, let me now relate it to real life examples. One of the application is, I call it facial recognition or voice recognition, right? So what we want is people to use a camera, use our PSOC Edge product, and let's say instead of you carrying a badge, you just show your face, and it recognizes your face, and now we want to make sure it doesn't get hacked. So somebody, I'd say we want to be able to replace the badge with either voice or image, depending on the security level that the customers care about. And we have live examples of that. Like we have a customer that's like, hey, we operating heavy machinery. We only want a few really well-trained drivers to be able to start the car or the machine, right? And so we want to become, pairing up with the security cameras to really be the solution here. And therefore, the highest level of security is needed. And you want to protect against all these things. So hopefully this gives an answer to your question.
Thank you, Sam. Tell us about your vision for the AI-enabled IoT. We had a few examples throughout the conversation of applications or application spaces that the AI could help, but what kind of applications do you hope to enable with the PSOC Edge family, say?
Yes, this is my favorite question. Voice. Yeah, I mean, this is really why we're doing all of this, right? So
exactly.
Voice and vision recognition are the key differentiator for Edge AI. Right, we see these capabilities deployed in activation control for advanced HMI interfacing. Vision-based position detection, face object recognition, tracking. So examples, security cameras. The other big example is unplanned downtimes. For industrial manufacturers, there's a whole slew of applications there. I mean, we're talking to some of these home appliance guys, and here, like the one people can relate to, drying time, right? People want to optimize. They don't want to go to the dryer 2-3 times and still their clothes are wet and have to figure out how long they should do it. We want automatically to use AI based on the load and size and how wet the clothes are to determine the drying time. Another manufacturer told me, look, I make my air conditioner, it's perfectly not noisy, noise-free when it comes out of the factory. When it gets installed in the field, well, maybe somebody doesn't tighten up the screw enough, or they put it tilted a little bit, and then the frequency where there's no noise is different than what I've tuned it in the field. Or so I need to use AI to at the edge in the field to determine what should be the optimal frequency for vibration. Other examples, the elevator determining, when do you need to do maintenance on it, or not just the elevator, many other things. Going forward to smart glasses, wearables, point of sale. So we see the applications exploding that could benefit from this, and that's what's exciting about this whole opportunity here. And and our product. And really, to me, we're still, I would call it scratching the surface. And yes, while adoption time it's taken time to improve it, I really see it being the way to work going forward. So our mission is, how do we make it cheaper? How do we make it easier for the customers to adopt it in order to make all these qualities much better going forward? So.
Yeah, I agree with you. I think we're just scratching the surface at the moment. I definitely want those smart glasses, for example.
That's right.
Thanks so much, Sam. Great conversation. Any final words for the audience?
Well, I'd say I would reiterate 3 points. One is Edge AI brings reduced latency, power efficiency, better security. They're needed to become essential for the next generation of IoT devices. Number 2 is markets like smart home, health and lifestyle, industrial, automotive. They will incorporate more AI ML enabled use cases like speech, vision, and that's only going to explode and expand significantly. And the last point, obviously, is to advertise about our company and our solutions. Infineon is really geared to provide the right mix of products to help with the digitalization and offering a variety of solutions to designers and developers in all of the IoT sectors. So please use us.
Perfect. Thank you so much, Sam.
All right. Thank you, Sally.
Thank you very much, Sam Jaha, for the thoughtful conversation about the AIoT. This episode of AI with Sally was brought to you by Infineon Technologies. Thank you very much, Infineon, for sponsoring us. If you want to learn more about Infineon's PSOC products, Imagimab or Deepcraft, or Infineon's other embedded AI offerings, please check the links on the podcast page at eetimes.com. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to articles on topics we've discussed are shown on your left. AI with Sally is brought to you by AspenCore Media. The host is Sally Ward-Foxton, our project manager is Colleen Heckman, and the producer is James Eade. Thank you for listening.